In terms of syncing part of our mechanical flower and the vibrating bracelet, we use Particles SDK for JavaScript and Node.js for that. And here are some code snippets. So basically what it does is that it uses my access token to access Particle account and also have access to our Photon devices. And after we run it, it basically gives some response. It shows some information about the linked Photon devices. And how it does it is we have this website built where if we press this turn on button, it sends an event through the Particles API to our Photon devices, which are connected to our mechanical flower and the vibrating bracelet. And after we send an event, they react to that and run the corresponding code. So if we press the button, for example, it sends the event request sent successfully, and it should turn on the photons linked to the flower and the bracelet.
We first decided that a reasonable breathing pattern should consist of looping cycles. In each cycle, the user will inhale for 4 seconds, hold their breath for 1 second, and exhale for 4 seconds. Between cycles, there should be a half-second pause. This is a code for the vibrator. After a lot of testings, I picked 5 effects from all the effects the motor driver can create to form a period of vibration, whose frequency and intensity can change continuously. To implement the inhale phase, I created a nested for loop. To have the driver go through 5 effects in total, from the weakest buzzing to the strongest, and last 800 milliseconds during each effect, so that the inhale process will last 4 seconds. And a similar nested for loop controls the exhale process, the only difference being the driver will go from the strongest effect to the weakest. For the servo, I also have to do a precise time control. The servo will need to rotate 90 degrees clockwise in exactly 4 seconds to pull the pedals and make the flowers close, mimicking the action of breathing in. And after 1 second for holding breath, it will again rotate 90 degrees counterclockwise in 4 seconds. What I did is calculating the time each rotation will take in order to reach 90 degrees and using that to control the movement of the servo. With delays added to represent holding breath and short pauses, we complete the code. Both programs are activated and terminated by a web page users can access. The main challenge are that precise calculations and an iterative design process to test multiple looping functions, as well as different combinations of publish and subscribe are required.
For the production of the bracelet, considerations had to be made for the appropriate length on the wrist, the thickness of the hinge patterns, the incorporation of a vibration sensor, and the method of connection. First, considering that the material was wood, we tested the thickness of the hinge pattern to ensure it wouldn't break. After making several sketches with slight variations and printing them for multiple times, we found the right thickness that wouldn't break and would bend well to match the wrist thickness. The overall length of the wristband was initially too long in the first attempt and required adjustments.